Today we discuss about a solar photovoltaic system with a resilient operation at weak grid conditions with flexible adjustment of DC voltage for the purpose of power quality improvement. So in this paper, we are going to discuss about the role of weak grid condition. My means power quality problems rises at the distribution grid side. Okay. So at that moment, what the proposed method is going to do, and also we are using advanced filtering grid filtering parameters to improve the power quality. So how we are going to perform all these things, I will show you here. So this is the block diagram. So initially we just run the models. I'm going to discuss about that one. I'm just initially running the model. Don't worry, we need I explain everything. Okay. So you already know the basic power generation from the PV panel. That means PV array is there, and then boost converter, and then inverter, and then filter. Then you connect it to the grid tied connection and to the non-linear loads. And ripple filter, you can reduce the ripples across the PCC point or point of interconnection point. Okay. And here we are using synchronous reference frame add-on with the other control strategies. In these are the conventional method, but the proposed method is going to discuss about the. I will show you here the block diagram. It is easier to tell all these things in this concept. Okay. So first we are using pre-filter voltage filtering purpose. This diagram is preferred, and then we need to convert into whatever the point of common coupling voltage peak magnitude is feedback here, and then from here to here we are getting ABC terms. Then we are going to convert into ABC to alpha beta here. Why we are using two voltage filtering means to reduce the power quality issues. That means in order to reduce the THD, we are using this proposed method. And then when we are this is the second system voltage filtering design, and then we are using alpha beta not to ABC transformation. And the major role here is load current weight estimation is the major thing. So how we are going to perform that one means with the help of the design above. And also here we are add on the sample and hold and zero cross detection, all these things to estimate the load fundamental component. That is the major thing actually in this control part. So that's why this plays a major role. And also these two controllers can these two estimators can filters the harmonic component. By filtering these part, we can easily separate the fundamental component with the harmonic components by the advanced control strategy. So this is the advanced control strategy to can it can differentiate between the fundamental and harmonic components. Okay, and you know the majorly here we are going to use hysteresis current controller. I already previously delivered related to the hysteresis current control. We just prefer previous classes regarding to hysteresis current control. So I'm just going to discuss about the cases here. I will show you the cases in simulation model. So same design we are going to design in MATLAB itself. In initial case, we are uh, at the first case. Okay, the result of the first case, a load one phase is going to off at the time interval of 0.6 to 0.7. So at that time, what are the parameters changes from the generation to the load? I will show you here. We just need to take the results, whatever they mentioned. Okay, I just give you the results here. You just need to count from 0.55 to 0.75. So you just zoom the parameter from 0.5 to 0.75. So up to here is enough. So if you observe the waveform means you can get One phase is shorted at the time interval of 0.6 to 0.7. You can easily observe in this diagram. So at that time, automatically there will be a variation in the DC link and load voltage, load currents, all these things we can observe variation. Okay. Suppose if you change any, if you change either in generation or in load terminal, automatically we can figure out the changes in the terminal points. Okay. And in second case, we are going to change the PV panel radiation. Okay. PV panel radiation will be changes at the time interval of 0.6 to 0.7. We are considering 500 Weber per meter square, and remaining times will be 1000 Weber per meter square. Okay. Here I am taking load will be constant. And I just open the control strategy for your sake. I just open this control strategy, and here also. So these are the estimators. Okay, right. Estimators can separate the fundamental components to the harmonic components, and these are the controllers to. This process is similar for every design. Okay, it's not. Again, we don't need to discuss all these things, but it is the similar for every case. Okay, and second case we just change the radiation and load will be kept constant. Okay, then automatically the waveform will be look like this from 0.6 to 0.7. This is the case we need to consider. So this is the waveform that will be took like this way. Okay. So this is the figure number 4. And in figure number 5, there will be problem in the grid. I mean, this is we are already title can deliver the weak grid conditions means at grid side and at distribution grid side having the problems. That means harmonics will be injected at this point. Okay, from here to we can inject the harmonics. So at the time of the injection of harmonics, the waveform will be look like this way. Where I am injecting harmonics means from here to here. So from here to here, I am just injecting the harmonics. So this is the waveform for the injection of harmonics. You can clearly observe here. Okay, from here to here, it is easier to show. Okay, the variation will be like this way. And the final result regarding to this one, you just mentioned a swell case in phase A. Okay, we are just performing. If you observe here, the grid phase A magnitude will be increases. Okay, remaining will be constant, but phase A will considered as a swell. Swell means somewhat of voltage will be increased at the sending side. Okay, so suppose if you consider 230, 500 is the reference here. No? So you just consider 415 is the terminal peak magnitude, but there will be a variation in the phase A. That means nearly 460 or 470. In this waveform, they are taking up to 480 itself. Okay, I just also show that waveform by running this model. So this is the variation in phase A. Okay, right. So in this manner, we can control any situation at weak grades, or else if you change at the low terminal, or if you change at the solar panel, the design can withstand at any parameters. Okay, that is the advantage of the proposed design. You can add on more to the. I mean, if you want to add on more extensions, means it depends upon the design you require. Okay, right. So this is the overall thing related to the solar integrated with the grid connection by using grid voltage filtering method. So these are the results. So thanks for watching this video. Okay.